I'll just start by thanking Science Disrupt for inviting me to speak today and for organizing this fantastic evening. So I'll be shifting the conversation a bit more from towards energy access, and in particular looking at a solution that my company has been developing to address the energy access trilemma. Mandulis Energy is a developer of power projects that are software enabled. We're based in a little spectacular country in the east of Africa. Not that I'm biased. Okay, yes, I am completely biased, but look at that view. Now, grid access is sparse, and only 19% of households actually have access to electricity. And even with that, transmission and distribution results in high amounts of energy losses. Nearly 20% of electricity is lost at that stage, and you can compare that with around sort of 8% in OECD countries. So as a result, you find that it's incredibly unreliable. The grid itself is incredibly unreliable. Nearly half of the customers on the grid only get reliable energy access maybe 4 hours a day. And actually, like most traditional grid systems globally, it's a centralized distribution model. And that means that it's highly vulnerable. And it doesn't take much to disrupt power supply. Lightning bulb, bolt, fallen tree, or demand rising. Demand, which is stochastic, but also rising currently at a rate of 10 to 12% per annum. And it's expected to continue to grow at that rate up to 2020 and even beyond. And if you look even further, you'll see with the inevitable adoption of electric cars, you can only expect that to continue to contribute to this issue of unreliability of the grid. So of course, with an aging grid system, the vulnerability actually increases even more. And then the cost of replacing this is nearly prohibitive. And right now, the total generation capacity installed is at about 853 megawatts. But roughly 80% of that is hydro. And what you find is just because of the hydrological conditions, you end up with peak generation that is actually trailing at about 60% of what it could be, and it's actually trailing demand. And that means power outages are the norm nearly every other day, and it can last minutes, hours, days, costing millions to businesses and industry. But not only within Uganda, but across Africa, power outages are responsible for nearly 2% of losses that are worth nearly 2% of GDP. So as a result, consumers are turning to solar, but solar is still unreliable, and other consumers on the grid use diesel. And so you end up with quite an interesting mix of essentially independently owned energy generation resources. And this actually creates a surplus which is currently not being exploited. So a classical example would be a sugar factory like Kakira, one of the biggest sugar factories in East Africa. They use bagasse, which is when you get the sugar cane, squeeze it, you end up with the leftover that you get at that stage is what they use essentially to run the bagasse plant. They have a 50 megawatt plant, and they feed part of that to the grid. Other ones typically rely on diesel. And by that I mean nearly 90%, because this is an environment where up to 90% of manufacturing is handled by SMEs. And that actually equates to 80% of manufacturing output and is 20% of GDP, basically. So that's a significant amount of economic activity going on. And so all of that ends up having to rely on diesel. So our solution is to take essentially what we see as the least cost approach to addressing all of these challenges using the existing infrastructure. And an evolution from a human-centered approach to a machine-centered model for distribution, with real-time, autonomous, data-driven decisions. Just think of it as a sort of a game-based energy management. So a mathematical coupling of three elements: source, load, storage, and essentially winning the game by maintaining a stable and efficient system. So we essentially create a virtual local distribution network, one that seamlessly integrates all these independently owned energy resources, and then also makes use of the existing grid infrastructure. And by adding to that a layer of microcontrol and management for the local distribution circuits, you end up in a scenario where you can actually make use of the optimized demand-based sharing of the surplus electricity. And at this level, this ends up having actually a number of benefits. One being reducing that peak demand alleviates the need to upgrade the power systems infrastructure to meet the growing demand, but also shifting the peak and smoothing out the demand curve can actually result in lower average losses in the distribution system. The blockchain payment sphere is mature, and Ethereum contracts allow us to match distribution with real-time transactions peer-to-peer. So essentially, settlement times become instant, and that brings them down from what it would have been otherwise, which is months. So we end up creating value for the entire ecosystem. The consumers on the grid end up with more reliable power, and those consumers that actually own their own energy resources, think of it as a sort of an Airbnb for those who own energy resources. You've got some surplus, and you essentially, shift that along to your neighbor for a nice fee. And the grid operator ends up actually addressing some of these issues of electrical efficiency on the grid. So what actually has happened in Africa is that if you look at a parallel, so in the financial services sector, the success of banking needed a blurring of the lines between mobile phones and banks. And likewise, we see that for energy access to succeed, to increase connection numbers, electricity and internet are critical to addressing these key bottlenecks. And it's scalable. So our solution, we see it as being scalable across Africa and potentially even globally. Our team has a broad set of skill sets going across from data science, software, engineering, product design, and project development. And we're currently working on developing our prototype with the view to getting a pilot towards the sort of Q4 of this year. We work with a number of partners, and we've received investment from African Development Bank's Sustainable Energy Fund for Africa, Power Africa, KfW, and we work really closely with San Francisco-based engineering firm Tetra Tech, as well as the French charity Acted. Thank you.